Przybylski's star defies all understanding of what stars should be like. Przybylski star is a type of Class A star, which are some of the more common stars you can see with the naked eye. They're not too rare, and they're also pretty bright. And most stars of that type are basically pure hydrogen and helium, with, a smattering of elements like calcium, magnesium, silicon, and iron. All fairly light elements. They also rotate about their axes on average about once every few days, and their brightness is pretty steady. And then there's Przybylski's star, a strange star discovered about 60 years ago, located 356 light years away. First, it oscillates in brightness super rapidly, going through one cycle about every 12 minutes. And while there are speculations that the rapid pulsation has something to do with its strong magnetic field, there's not really a clear answer there. And that's not all. For some strange reason, it takes at least 188 years to spin about its axis. In fact, it's so long that we can only know that there's a lower bound on the length of one rotation. But the fact that it rotates so slowly and has such a strong magnetic field might be the reason why we see its third and most unusual property. This star is made of elements not found in any other star, and it's extremely low in iron. In particular, it has lots of heavy elements, and no one knows why. For example, it has lanthanum, cerium, praseodymium, neodymium, samarium, all appearing in its spectrum. And even stranger still, it's believed that it has short-lived radioactive elements, which is baffling. After all, that would mean that something is constantly sourcing those atoms, since they couldn't have formed with the star. Unfortunately, the complex and strong magnetic field of the star makes it really hard to definitively tell which heavy elements are present and in what concentrations, especially because these elements don't have accurately measured spectra. As recently as 2022, a group in Ukraine showed that there is probably not any technetium in the star's atmosphere, and while it can't be ruled out, the presence of promethium, which has a half-life of only 18 years, cannot be definitively said to be present. And even heavier elements like plutonium, californium, and einsteinium have been claimed to be detected. Of course, the evidence for these are much weaker because we have even less information about their spectra than the lanthanides. But keep in mind, the longest-lived isotope of einsteinium has a half-life of just over a year. So how did these elements get here? Well, it's been speculated that this is evidence of the island of stability, a theoretical region of the periodic table composed of relatively stable super-heavy elements. The idea is that there might be a large pool of slowly decaying super-heavy elements which eventually decay to the elements that we detect in the star. On the other hand, Carl Sagan speculated it might be aliens. Przybylski is not... Przybylski. Przybylski. Przybylski's... And then there's Pzybyl... And then there's Pzybyl... And then there's Pzybyl... And then there's Przybylski's. No? And then there's Pzybyl... And then there's Pzybyl... And then there's Pzybyl...